This video is about part 2 of solving a system using substitution. So before we start solving using substitution, we need to talk about another step that we're going to add in. So this time, instead of just having a y equals or an x equals, we have to isolate one of them. So when we're trying to isolate a variable, we want to figure out which variable has a coefficient of 1. So in number 1, we would solve for x by moving the 3y to the other side. And then we would have our isolated variable. So if I subtract 3y from both sides, now this looks like an equation that we would have used yesterday. In number 2, the y in the second equation has a coefficient of 1. So when I subtract 4x from both sides, this would have looked like an equation we would have used yesterday. So we're just adding in one more step of having to get a variable by itself first. So in the substitution method, the first step is to solve for one of your variables, either get x or y by itself, and then the steps that we did yesterday. So we're going to substitute and solve, and then substitute the number and solve again. So in number 1, we have x minus 2y equals negative 25, and 3x minus y equals 0. So in order to get x by itself, because there's a coefficient of 1, we're going to add 2y to both sides. So this equation now changes into x equals 2y plus 25. Now that we have x by itself, we're going to box what x is equal to from the first equation and box x in the second equation, and now we're going to be able to substitute. So we get 3 parentheses, and we're going to put in what we're substituting. So 2y plus 25 minus y equals 0. So the first thing I'm going to do is I'm going to distribute. So I get 6y plus 75 minus y equals 0. Then I can combine like terms. So I have 6y minus y, which gets us 5y plus 75 equals 0. When I subtract 75 from both sides, I get 5y equals negative 75. And when I divide by 5, y is negative 15. Once we know y is negative 15, we have to go back and solve for x. So I'm going to take the y value and I'm going to substitute into the second equation. It doesn't matter which one you use, but this time I'm going to use the second. So 3x minus parenthesis negative 15 equals 0. So remember, two negatives make a positive, so 3x plus 15 equals 0. We're going to subtract 15 from both sides and then divide. So we get x is negative 5. So our ordered pair would be negative 5 comma negative 15. In number 2, we have x plus 5y equals 4 and 2x plus 10y equals 28. So again, in number 4, this x has a coefficient of 1. So we want to get that x by itself, so we need to move the y to the other side. So we're going to subtract 5y from both sides, and we get x equals 4 minus 5y. So now we're going to box what x is equal to, and we're going to substitute for x in the second equation. So we have 2 times 4 minus 5y plus 10y equals 28. So when I distribute, I get 8 minus 10y plus 10y equals 28. Combine like terms, negative 10y and positive 10y becomes 0, so we just have 8 equals 28. So this is one of our special cases. Remember that 8 does not equal 28, so this is an example of a no solution. So remember, when your variables cancel out, that's a no solution, and then we just stop. We don't have to go back and get the other variable. It's one of our special cases. Number 5, we have 2x plus y equals 20 and negative 3x minus 3y equals negative 60. So in this case, the variable that has a coefficient of 1 is the y in the first equation. So we want to get that y by itself, so we're going to subtract 2x from both sides, and we get y equals 20 minus 2x. So now I'm going to take what y is equal to, and I'm going to substitute for y in the other equation. So I get negative 6x minus 3, parenthesis 20 minus 2y equals negative 60. So when I distribute, I get negative 6x minus 60 plus 6x equals negative 60. So when I combine the x's, I get 0, and I'm left with negative 60 equals negative 60. This is a true statement, so this is our other special case. So remember, when this is true, we're going to have infinitely many solutions. Let's look at one more problem before we get into our word problems. So in number 6, we have x plus y equals 7 and 5x minus 2y equals 21. When both of them have a coefficient of 1, so in the first problem like x and y, it doesn't matter which variable you solve for. So I'm going to solve for y, so I'm going to subtract x from both sides. Y equals 7 minus x. So I'm going to substitute what y is equal to into the other equation for y. So I have 5x minus 2, parentheses 7 minus x, equals 21. So in order to solve, I need to distribute. So 5x minus 14 plus 2x equals 21. I can combine my x-like terms. So I get 7x minus 14 equals 21. I can add 14 to both sides, so 7x equals 35. And I can divide by 7, so x is 5. Once you know x is 5, go back and substitute. So if I know x is 5, I'm going to put that into the first equation to get y. So I have 5 plus y equals 7. I can subtract 5 from both sides, so y is 2. So my final answer would be 5, 2. Now let's look at some word problems. Number 7, the local movie theater charges $5 for students and $8 for general admission tickets. If 280 tickets were sold on Friday afternoon for a total of $1,691, how many of each ticket were sold? So the first thing we need to do is we need to identify our variables. So there's two types of tickets that we have being sold. We have S for student, and we have G for general admission. Now, there's two totals they gave us, how many tickets we have and the total money. So to get the total number of tickets, we're just going to add the people together. So S plus G equals 280. And then we're going to do the same thing with money to get 1,691. So there's $5 per student, so 5S plus $8 for general admission, 8G equals 1,691. So now I need to get a variable by itself. So I both have S and G here. I'm going to subtract G from both sides to get S by itself. So S equals 280 minus G. Now that I have S by itself, I can box what S is equal to and box S in the other equation. So now I'm going to substitute. I'm replacing S with 280 minus G. So I get 5 times 280 minus G plus 8G equals 1,691. So when I distribute, I get 1,400 minus 5G plus 8G equals 1,691. When I combine like terms, I get 1,400 plus 3G equals 1,691. I can subtract 1,400 from both sides, so I get 3G equals 291. And when I divide by 3, G is 97. Now that I know G is 97, I can substitute. I'm going to use the first equation because there's less exponents and less work to have to do. So I'm going to substitute that in for G. So I get S plus 97 equals 280. And when I subtract 97 from both sides, I get S is 183. So remember, with ordered pair, go in alphabetical order if they're not X, Y. So we have 97, comma 183. We also need to write a sentence because it's a word problem. So there were 97 general admission tickets and 183 student tickets sold. Let's look at one more word problem. So in number 8, the softball season is around the corner and the coach needs to order some new equipment for some of the players. The coach ordered a total of 13 items for a total of $2,675. The coach ordered gloves for $63 and bats for $295. How many gloves and bats did the coach order? So when we need our variables here, we're looking for gloves and bats that were ordered. So we're going to say G is going to be our glove and B is going to be our bat. So there's two totals. There's 13 items and the total cost. So when we add the gloves plus the bats, they should equal 13. And then we need to include our money. So 63 times G plus 295 times B equals 2,675. So now I need to get one of the variables by itself. So this time I'm going to get G by itself. So I'm going to subtract B from both sides. So I get G equals 13 minus B. So I can box what G is equal to, and I can box G in my other equation. So I get 63 times 13 minus B plus 295B equals 2,675. So when I distribute the 63, I get 819 minus 63B plus 295B equals 2,675. So I can combine those B terms, and when I combine those, I get 819 plus 232 equals 2,675. I can subtract 819 from both sides, and I get 232B equals 1,856. When I divide by 232, I got 8B. So I can substitute 8 back in for B, so I get G plus 8 equals 13, which means that G is 5. So remember, when we write our ordered pair, we're doing alphabetical order, so we have 8, 5, and we also have to say what this means. So the coach ordered 8 bats and 5 gloves.